In this video, I will show you how to graph and label an ellipse, and I will show you how to write the standard form equation of an ellipse given information like this, or given the general form equation. The first thing we need is the center of the ellipse. Now, in a problem like number 9, the center would be -1, 2, the opposite of these. But in a problem like number 8, nothing is added or subtracted. That tells us that the center is 0, 0. So here's the center of the ellipse right here. Now, find the bigger denominator. The biggest denominator is called a squared. So a squared is 36. That means that a is 6. Because the 36 is with the y term, we will do plus and minus 6 in the y direction. So we will go up 6 and down 6. These are the vertices. So the vertices of the ellipse are 0, -6 and 0, +6. Now, the smaller denominator is b squared. If b squared is equal to 4, that means b is equal to 2. Because the 4 is with the x term, I will do plus or minus 2 in the x direction. So I will go 2 to the left and 2 to the right. These are my co-vertices. So my co-vertices are -2, 0 and +2, 0. Now we need to find the c value so we can locate the foci or foci. We know that for ellipses, c squared is equal to a squared minus b squared. So that means c squared is going to equal 36 minus 4. So c squared is 32. That means c is equal to the square root of 32. Because 32 is 16 times 2, then c is 4 radical 2. Checking the calculator, I see that the c value is approximately 5.7. I just need this for graphing purposes, so 5.7 is really close to the vertices. Okay, and the foci always line up with the vertices. So be careful when you name the foci, though. We have to use the radical form. So the lower focus has coordinates 0, -4 radical 2. The upper focus has coordinates 0, +4 radical 2. E stands for eccentricity, and eccentricity is always the c value divided by the a value. Okay, in this case that means 4 radical 2 over 6. I'm writing it up here because this can be reduced. So this reduces down to 2 over 3. So 2 radical 2 over 3. Then all that's left is the drawing of the ellipse. So that will do it for number 8. Looking at number 9, first we have to talk about the center. The center is the opposite of this and the opposite of this. So the center will be -1, +2. Let's go ahead and graph that. -1, 2, the center is here. Next, look at the bigger denominator and call it a squared. If a squared is equal to 25, that means a is 5. Because the 25 is with the x term, I will do plus and minus 5 in the x direction. So I will go 5 to the left and 5 to the right. These are my vertices. So my vertices are -6, 2 and 4, 2. Now let's find the b value. Well, b squared is going to be the smaller denominator. If b squared is 9, that means b is 3. Because the 9 is with the y term, I will do plus and minus 3 in the y direction. So starting from the center, I will go up 3 and down 3. These are my covertices. So my covertices are -1, -1, and -1, 5. Next, I need to find the c value, so I can locate my foci. We know that c squared is equal to a squared minus b squared. So c squared is going to equal 25 minus 9. So c squared is equal to 16, which means that c is 4. Okay, look for the vertices. The foci will always go on the major axis, always the long way. So in this case, that means going to the left and to the right. So if I go 4 to the left, there's a focus. If I go 4 to the right, there's a focus. Okay, so my foci are then -5, 2, and 3, 2. Okay, that was a little disappointing. I was hoping that the c value would be a radical, so I could show you how to do it. I hope I'll have an opportunity on another problem. We still need the e value. The eccentricity is c over a. So in this case, that's just 4 over 5. For number 10, we need to write the standard equation for an ellipse that has these vertices and these foci. If I do a quick sketch, it will help me visualize what's happening. So let's see, 5, 0. That would be here. -5, 0. Wait, let me put this 5. 1, 2, 3, 4, 5. Those are my vertices. Right away I can see that the center is 0, 0. So that immediately tells me that I have x squared and y squared in the numerator because of 0, 0. Now, this also tells me the a value. The a value is always going to be the distance from the center to a vertex. So a is 5. That means that a squared is 25. Because the a value is horizontal, that's the x direction, I will put the 25 with the x term. Okay. They also gave us the foci, or foci, which are 3, 0 and -3, 0. This indirectly gives us the c value. So c is equal to 3, which means that c squared is 9. So we can use these values to find b. We know that c squared is equal to a squared minus b squared. So 9 will equal to, this is a 9, will equal 25 minus b squared. All right, I'm going to really switch the b squared and the 9 by adding b squared and subtracting 9. So the b squared will end up over here, and the 9 will end up over here. So this means that b squared is equal to 16. So the b squared goes here. So this is a standard form equation of the ellipse that has these vertices and these foci. Okay, number 11. Again, we're finding the equation of an ellipse, but this time we're given the vertices and the co-vertices. Let's do a sketch. Okay, so -4, comma, -3. Okay, so this is -4 and this is -3. So here is a vertex. And then 6, comma, -3. Okay, so 6, comma, -3 is right here. These are the vertices. So these are at the ends of a horizontal ellipse. Let's figure out what the center is. I think it would be helpful to keep in mind the total distance between these two vertices. If it's 4 to the left, 6 to the right, that's a total of 10. That means if I come in 5 from either vertex, I should be at the center. So the center is right here. Whoops, I didn't mean to put it on the line. Okay, so the center is at 1, comma, -3. The center is right here. Now that's important. Okay, I'm going to write that down. So the center is 1, comma, -3. That gives me half of the equation right there. For ellipses, we know that it's always a fraction plus another fraction equals 1 in standard form. But because the center has an x-coordinate of 1, the numerator will be x minus 1 squared. I'm doing the opposite of this. And here I will have y plus 3 squared because of the -3. So I'm halfway done. But there's more. So since the entire distance from vertex to vertex, the major axis has a length of 10, then that means that this distance from the center to a vertex is 5. And that is my A value. So A is 5. Knowing that A is 5 tells me that A squared is 25. Because this 5 is in the horizontal direction, that's the x direction, the 25 goes with the x term, like that. So now I need the b value. Let's go ahead and graph the covertices and we will find the b value. So I have a 1, comma, 0 for a b value. That's right here. And then I have 1, comma, -6. Interesting. So there's -3, so -4, -5, -6. So I have a covertex here at 1, comma, -6. Well, hopefully you can see that the distance from a covertex to the center is 3. So that tells me that b is 3, which means that b squared is 9. Because this 3 is in the vertical direction, the y direction, it makes sense that this 9 will go with the y term. And that's it. This is the standard form equation for the ellipse that has these vertices and these covertices. All right, let's do that again. Start off with a nice diagram. The vertices are 3, comma, 6. All right, so there's a vertex. And 3, comma, -6. Okay, look at that symmetry. Up 6, down 6. That tells me that the center is going to be right on the x-axis at the point 3, 0. So I know that the center is 3, 0. That's going to give me half of the equation right now. Okay, because of the 3, I'm going to have x minus 3 squared. I do the opposite sign. Because of the 0, nothing is being added or subtracted from the y. So I'll just put y squared. But there's something else that I know. The distance from the center to a vertex is 6, obviously. So that tells me that a is equal to 6. That means a squared is 36. Because this a value is vertical, it's in the y direction, this 36 will go with the y term in the denominator. So let's plot the covertices and find the b value. Covertices are at 0, 0 and 6, 0. So 3, 4, 5, 6. So 0, 0 and 6, 0. These are my covertices. Okay, hopefully you can see that the distance from 3 to 6 is 3. So that tells me that the b value is equal to 3. That means b squared is equal to 9. Because the b is horizontal, that's the x direction. So it makes sense that this 9 is going to go in the denominator of the x term. And that's it. This is the standard form equation of the ellipse that has these vertices and these covertices. Number 13 is very similar, but they gave us the center immediately. So we can write half of the equation right now. Because the x-coordinate is 3, we know we will have x minus 3 squared. Because the y-coordinate is -1, we know we will have we know we will have y plus 1 squared. Now, they told us that we have a vertical major axis of length 6. So this is the major axis, and the length is 6. We can use this to know the a value, because if the major axis is 6, that's this entire red line. The a value is only going to be half of that. So a must equal 3, which means a squared is going to equal 9. Because this is in the vertical direction, that's in the y direction. So this 9 will be in the denominator of the y term. They told us that there is a horizontal minor axis, length 4. So this entire green line from one side to the other has a length of 4, which means that the b value, which only goes from the center to a covertex, is going to be 2, half of this. So if I know that the b value is equal to 2, that tells me that b squared is equal to 4. And again, this is horizontal, that's the x direction, so it's no surprise that this 4 goes with the x term. And that's it. So this will be the standard form equation of the ellipse with this center and these major and minor axes. Okay, in problem number 14, we need to take this general form equation and write it in standard form with the parentheses and such. We're going to need to complete the square, but our first step is to group together the x terms and the y terms. So we have 16x squared and we have 32x. Those have to go together. We have 4y squared and we have negative 8y. Those need to go together. Okay, so I'm going to write 16x squared plus 32x. Alright, now I've grouped the x's together. Then I will have the 4y squared minus 8y, because now I have grouped the y's together. And that's going to equal the 44. Now I need to complete the square. So because I have this number in the front, I need to factor that outside of parentheses. So I will have 16, and then inside of the parentheses I will have x squared. 32 divided by 16 is 2, so I will have 2x. I will leave space to complete the square, and I will do the same thing with the y's. This 4 in front of the y squared needs to come outside of parentheses, so I will have y squared. Negative 8 divided by 4 is negative 2. So, whoops, almost put an x. Negative 2y. Again, I leave a space at the end to complete the square, is equal to 44. So when we complete the square, we think half the middle squared. So half of this is 1. 1 squared is still 1. So I'm going to have a plus 1 here. Now I need to balance that out on the other side of the equation, but I'm not going to add 1 because this is really 16 times 1. So I really have to add 16 to the other side to balance this out. Imagine the distributive property. Similarly here, half of this is negative 1. Negative 1 squared is again positive 1. But again, I need to multiply by this number in front of the parentheses to see what it will take to balance that out. So 4 times 1 is 4, so I will need to add 4 on the other side to balance out this change. Okay, now let's factor. I will have 16, and this trinomial will factor as x plus 1 times x plus 1. Okay, the point of completing the square is that it will always factor as the same binomial twice. Same thing right now. This will factor as y minus 1 times y minus 1. Okay, since the middle term was positive right here, I know these will be positive. Since the middle term was negative here, I knew these would both be negative. So now I just need to add up these three numbers. So that turns out to be 64. So now I have 16 times, and I can write x plus 1 squared because there's two of them. And then I have 4 times y minus 1 squared is equal to 64. The standard form equation for an ellipse always has a 1 right here. So I need to divide by 64 in order to get that 1, which means I have to divide everything by 64. Okay, how many times does 16 go into 64? 4 times. So if I reduce this fraction, I'm going to wind up with x plus 1 squared over 4. And then that means 4 must go into 64 16 times. So this fraction will reduce down to y minus 1 squared over 16. And all of that will equal 1. So we have found the standard form equation of this ellipse. However, they want us to write a bunch of stuff. Oh, looks like I should have written the equation here. Let me do that. Okay, so we need to find A, B, and C and other things. So I think I'll go ahead and write down the center first. The center is going to be the opposite of this and the opposite of that. So the center will be negative 1, comma, positive 1. So there's my center. Now, how about the A value, B value, and C value? We always let A squared equal the bigger denominator. which means that A must be 4. Okay, so the A value is 4. We always let B squared equal the smaller denominator, so that means B is equal to 2. So B is 2. Okay, how about the C value? We know that C squared is equal to A squared minus B squared for ellipses. Well, A squared is 16 and B squared is 4. So we can just go ahead and put 16 minus 4. So C squared is going to equal 12, which means that C will equal the square root of 12, which means C is equal to, keep in mind that 12 is 4 times 3, so this will simplify it down to 2 radical 3. Okay, so that is the C value, is 2 radical 3. Now, the E value, or eccentricity, is always C over A. So that would be 2 radical 3 over 4. However, this reduces. 2 over 4, of course, reduces to 1/2. So this E value simplifies to radical 3 over 2. Now they want us to find the vertices and co-vertices. To do that, I need to make a sketch. So let's see. Let me set up my my y-axis and my x-axis. So the center is at -1, 1. Okay, so fine. -1, 1. So here is the center right there. Now, let's start with the vertices. For the vertices, we will use the A value, all right, the bigger of these two numbers. Okay, now remember that we got the A value by looking at A squared, which was the 16. Notice that the 16 is with the y term. That means when I do my plus or minus 4 in a moment, I need to do it in the y direction. So I'm going to take that A value and I'm going to do plus or minus 4, but I will do it in the y direction, so up and down. So I should label this. So this is 1 and this is -1. So I'm going to go up 4. So here I go. 1, 2, 3, 4. So this is 4 now. So there should be a vertex right here. And this vertex is at -1, 4. If I go down 4, there should be another vertex. So that's down 1, 2, 3, 4. Okay, so this is -3 right here, but there should be a vertex here. And the coordinates of this point are -1, -3. So these are my vertices. Let's write them down. Okay, so I had -1, -3 for the lower vertex, and -1, 4 for the upper vertex. It's all about the sketches, people. All right, I encourage you not to try to visualize this completely in your head. Okay, now the co-vertices. The co-vertices we can find by using the B value, this 2. Remember that we got the B value by starting with B squared, which was 4. Notice that this 4 is the denominator of the x term. So when I do my plus or minus 2, I will do it in the x direction, left and right. So that's why I'm going to start at my center but I will go left 2 and right 2. So if I go left 2, here I go. 1, 2. So this is going to be negative 3. If I go right 2, it would be 1, 2. So this would be positive 1. So I should have co-vertices here and here. Alright, the coordinates of this leftmost co-vertex is the point negative 3, comma 1. The rightmost co-vertex is the point 1, comma 1. So let's write that down. Okay, now how about those foci? The foci have to always be on the major axis. So they're going to be on the same line with the vertices. Okay, so the foci will be above and below the center. How far above and below the center depends on the c value. Okay, so we have the c value of 2 radical 3. I'm checking my calculator right now for the decimal approximation. I'm actually typing in square root of 12. And I see that it is 3.5 approximately. So let's just take note of that. Okay, so C is approximately 3.5. That means my foci should be about 3.5 units above and below the center. So if I go up 1, 2, 3, I'm already there, so 3.5 is actually very close to the vertex. So you can bet that it will be the same down below. So 1, 2, 3, 3.5 would be about here. Now, when I label these points, I'm not allowed to use the decimal approximation. So you have to keep the following thing in mind. Remember, the coordinates of the center were negative 1, comma 1. Okay? We are moving up and down to get to these foci. That means we are going to we are changing the y value, but the x value will be the same. All 5 of these points are all lined up at negative 1. Alright, the green points, the pink points, and the yellow point, they all have the same x value. They are all having an x value of negative 1. So let's get that out of the way. Alright, we know for sure the x value. So that means this point is going to be negative 1, comma something. Same with this point right here. We know it's 1 to the left, so we know this will be negative 1, comma something. All we need to know is the y value. Start from the center. Look at the y value. It's a y value of 1. So what we do is we start with the y value of the center, and we're going to add something to get to the upper focus, and we will subtract something to get to the lower one. And what we're adding and subtracting is the c value, because we know that the distance from the center to a focus is the c value. So I'm going up by c, so I'm going to add c. So in this case, c was 2 radical 3. So I'm going to add 2 radical 3. Alright, that's the best we can do. Leave it as a sum. So the coordinates of this point are negative 1, comma 1 plus 2 radical 3. We started from a y value of 1. We went up 2 radical 3. Similarly, the lower focus, we started at 1, and we went down 2 radical 3. So that's minus 2 radical 3. So these are the coordinates of the foci. So that's going to be it for problem number 14. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.